So good afternoon, everyone. Thank you for joining us today on our SPADE webinar. We're going to discuss about our SPADE use cases and also the project itself. And the main point is we're going to provide with some kind of insight about standardization when it comes to our project and also what kind of standards that we are using here. And we welcome at least three esteemed speakers. First is Aristotle Garakis. He is the project manager of the SPADE project, and he is also a senior researcher at IPO and CERT. And for our second speaker is Flamming Span. He is from a project manager from Haventorm. And our last speaker is Antonio Kung. He's going to deliver some information and insight about the standardization on our project. Since we are already a bit late, so should we start immediately? And our first speaker is going to be Aristotle Garakis. So the floor is yours, Aris.
Thank you, Septian. I will give you a brief explanation and presentation about SPADE, what we're doing in SPADE. First of all, from the title of the project, you can see it's about multi-purpose physical cyber agri-forest drones ecosystems for governance and environmental observation. So it's all about drones and their use in agriculture and forestry mainly. First of all, what is the rationale behind this project? So why did we initiate the SPADE project? So as we all know, the use of drones is increasingly applied for agriculture and forestry. However, there are many risks that are related to drone operations that still need to be addressed. Such as cybersecurity breaches, physical and safety hazards, risks of human errors, and plus the technology is new, so the regulations are concerning drones are also new. New services and applications are emerging all the time in operations, and the technology is quite complex. So this is why SPADE aims. Well, we've already done a lot of steps on this towards that. We're developing an intelligent ecosystem. The scope is to address the multi-purpose concept of deploying UAVs and to promote sustainable digital services in the sectors of forestry, crop production, and livestock farming. The consortium consists of 21 partners from 9 European countries and one associate, the United Kingdom. It's a multidisciplinary consortium with experts from universities, research institutes, SMEs, um, consulting companies, and we also have cooperatives on board. So we are covering pretty much the whole list of stakeholders and developers. So now about the objectives. First of all, the main objective is for us to learn and engage others in learning about the risks of using drones and the multi-purpose utilization of these tools. Second, we are developing cost-effective drones within SPADE. We've already developed our flying platforms in SPADE for the use cases that we are utilizing in SPADE. Also to develop an open source, open access ecosystem with the SPADE platform in the center of this ecosystem. Then we address also the deployment of pilot activities in order to test all these developments. And finally, our last objective is to make the innovation known to and available to everyone. Now about our pilots, we have 3 pilots. The one is concerned about forestry. It's launched in Norway, and it's about inventory of forests and activities about harvest and other operations. The other pilot is about open field, about crop production. That one is installed in Spain, in the Balearic Islands, and different crops, potatoes and olives and citrus crops that are in terraced crops, as we say. that are difficult to reach in many locations. So in these cases, the crop scouting, disease detection, monitoring are really key aspects for that. And also the livestock pilot, that's in Greek, in a Greek island in Lesbos, with the use cases to promote and improve breeding via grazing and health monitoring of sheep flocks. For each pilot, we are addressing 3 different use cases in terms of size and operation. So we have small drones with forming a swarm to do some operations in different use cases for each pilot. The cooperative of medium-sized drones cooperating with each other, and finally the large drone operations for different applications. Apart from the physical aspect of drones, the flying machines, we also work a lot on policy aspects. So far, we have been mapping policies that are related to drones and are used in agriculture and forestry. We have grouped them according to the following categories. We have the operational aspects, environmental and ethics, data, and technical aspects. So we are following all these regulations, and we are taking into consideration in our reports. Also, we've done a lot of work in the standardization. Antonio will give you a better idea of what we're doing in the standards within SPADE. So we are contributing a lot in standards. And finally, this is my last slide about the SPADE ecosystem. So the main idea is that we have the SPADE platform, which is the heart of the system, where we have embedded the digital twin tools and services and data sets and repositories that can be exchanged through this ecosystem. So in these ecosystems, the 3 pilots are connected, and also the open calls, the products from the open calls that we are launching in SPADE for that, and they are developing extra services. And of course, we have the vendors that are connected to the platform externally. So this is briefly what's really briefly what we do in SPADE. We have a lot of developments that we are presenting, we are developing. Thank you for your patience, and Septian, I give the floor back to you.
Okay, thank you so much, Aris, for the project introduction. And then I would like also to remind all the participants that we have the Q&A session in the end of the webinar. So if you have any kind of question, you can already write your question in the box, and then I will try to moderate the question to the all specific speakers. So come to the next presentation is going to be from Flamming Span about the context of drone in the agricultural application. So the floor is yours, Fleming.
Yes, thank you very much, Septian. And I think I would like to continue where Aristotle left off. The term flying platform, I think, is a very good phrase to use in this context here. I've already been a project manager for several other similar projects, exploring some of the opportunities that takes place there, also in terms of the technological advancements and also the impact it has on rural communities. So essentially, when we are talking about drones and its role when it comes to ecosystems in general, you can see that it has evolved quite a lot. And what we have here is actually our favorite image of mine. This demonstrates some of the various services that you can have provided by drones in the agricultural context. You can see that we do address crop and herd management, which all are addressing, for instance, monitoring, mapping, spraying the field. You cannot see it, but I'm pointing at the screen right now here. And also using these new platforms as a way of combining data from numerous sources. So using drones in this context, they offer us both insight, and they do also support the investments that farmers need to do in order to get full results from both the crops and agriculture and livestock in general. So you can say that drones in agriculture have a direct impact, I would like to say, on the livelihood of farmers. So if you move across there and we take a look here at those cross-cutting pillars, then drones do not directly impact only agriculture. It has relevance to very many parts of the European rural development. And for instance, here you can see some of all the various parts where drones can address the important parts of the value chain. So we move from offering services to supporting communities. Antonio is going to talk more about this, but in the SPADE context, then we have this European deal that addresses sustainability objectives. So in this case, for instance, SPADE offers what you can call precision agriculture, and the Norwegian pilot do address precision forestry. We have all the elements here that do address the farm to fork, where chain resilience is a topic. In this case, you can see that SPADE offers last mile transport, also within the context of agriculture. This is something that matters quite a lot. We can continue focusing on here, but in general, SPADE offer what you can define as data-driven farming services. And if you look at some of the challenges that this offer in this context, you will see here that we have very fragmented ecosystem today. Within the sector that the drones within SPADE belongs, we have data silos where sharing data across the various horizontals has proven to be a difficult matter. Again, this is something that SPADE do address. Lack of standards is tied directly in with that. So looking into the framework, looking into the data spaces, looking into how this can be integrated within digital twins, all of those are also elements that have a great impact really on the success of using drones within agriculture. And of course, we have the last part that has to do with how do we support the insights that is necessary for decision making, decision support, if you like. So all of those are elements where SPADE, through its different pilots, are trying to address and demonstrate. Aristotle has already talked about some of the pilots that we are running. When it comes to the forestry, then you can say that both understanding about the harvest support, understanding what kind of tasks that is relevant, that's an important issue. When we have the livestock pilot, identifying not only grazing herds, but being able to count sheep, not to sleep, but to understand what's around, what's relevant, also guiding them to necessary fields. That is a very interesting use case. And the same goes, of course, for Spain, where we are going to have even more focus on how we can support agriculture in all its different sizes and forms. So this multi-purpose services that we are talking about here, this is all about how these flying platforms, UAV generated data, can feed into that value chain. We have several examples. I'm just going to jump right into what the demonstrations is going to offer. In general, these flying platforms, the drones, the drone technology, offers us an opportunity to have some kind of situational awareness, both to understand the various measurements and to identify some of the challenges and address them directly, and also tailor them to what matters, that address the different parts. Each of them have their specific challenges, and each of them have their different solutions. Here we have some examples where we'll just look at what you can save in time, what you can save in water, and what we can save in being more specific in terms of disease detection. So accuracy and understanding what takes place on the ground level, those are important elements. Again, I'm picking up the forestry pilot. I think that it do address many of these issues very well, both in terms of the at times challenging terrain that it do address, but also do address in particular when it comes to using the investment in large machinery. Using drones makes it very flexible, very versatile. It do not really cost all that much. And you can also say that it gives immediate feedback to the farmers. So turning it from being uneconomic to actually giving it, excuse me, a real advantage in that sense is something that really support I would like to say the entire economics of how the farmers manage it. You can also see that using that, again, I use the term flying platform, that uses camera, lasers, using AI to do detection, object segmentation, etc. All of those do also support what's going on at the ground level, in particular when you combine it with, for instance, satellite data. Talking about value chain, the value chain itself can be a rather daunting, I would like to say, component of this all. We have been talking about some of the findings that looks into certifications. This is a major obstacle, really, and this is something that we just need to adhere to and ensure that when we work within the frameworks that the various certifications and compliance thresholds do address. We also have elements that do directly impact how we use that drones, battery life, environmental adaptation. As you imagine, there is a limit to how long a drone can keep in the air. So using that and optimize the values that you can get from it while in the air is a topic. And of course, very important, drone as a data asset. And that is mainly what we have been talking about. In general, when we're talking about challenges and opportunities, we are looking into what can be achieved and what needs to be considered. So we are talking about investments, we are talking about the necessary know-how, and we are talking about how we should be cooperating. At the same time, you can see that we are looking into opportunities. We're looking into new business models. We are expanding the reach, and also the organizational models, something that is being, I would say, not only challenged, but enforced through use of drones. For instance, having remote operational control services, offering more direct situational awareness, introducing things like trigger mechanism. If something happens on the field, if you do identify that we have areas that is suffering from drought, or if there are areas that needs nutrients, all of those are elements. When it comes to livestock, having, for instance, perimeter management, offering personal guidance to people on the ground, all of those are new opportunities that exist. So completing what we have been discussing so far, both in terms of resilience and threat risk modeling, in particular when it comes to rural communities where you do have quite a number of issues that you need to take into account, supporting when it comes to decision support that we have been talking about. In the forestry, for instance, fire is a topic. When it comes to livestock, predators, understanding where predators are is a topic here. When it comes to other elements, understanding where landslides are taking place, all of those are use cases that are being supported by our drones and will have a major impact on decisions when it comes to agriculture in general. Talking about perimeter intelligence, won't go too much into detail, but ensuring that we can use the kind of information that we receive from drones, the flying platforms, in order to also adjust how they move, what they are going to look into, what kind of data that they are collecting. Those are relevant there. And of course, how to use that multi-sensor functionality to do other kinds of data gathering, tracking, sensing, using infrared cameras, using LiDAR in order to capture the terrain. All of those elements are past what we are talking about technology for technology's own sake, but instead do address the needs of the farmers, of the rural communities where we have primary business taking advantage of this. So building new horizontal services, passing those cross-pillar consideration we was talking about here, and moving into, I would say, not only management and resilience, but in general, a proper place in the community. That is where we are moving towards. So I think I'll just say thank you for your attention, and I throw the ball back to you, Septian.
Thanks a lot, Fleming, for the inspiring presentation. And since we don't have enough time now, so I would like to go to the main presentation today. It's going to be delivered by Antonio Kung. And it's going to be about the overview of standards and also roadmap on behalf of SPADE project. Antonio, it's your turn. Thanks.
Thank you. Hello, everyone. Sorry, I was late in my joining the workshop. Okay, so I'm going to present an overview of standards and roadmap related to what we did in SPADE, the two inspiring presentations from Aris and from Fleming. Okay, so first of all, a word on myself, then I'm going to show how I'm going to present this galaxy of standards, focus on drones, digital twin in data space, and AI, okay? So first of all, I'm from Tronkog, former CEO, but really involved in standardization. I'm chairing the working group standardization in AIoTI in BDVA. I'm involved in many committees, and I work in several aspects, okay? So many of them, I would say, okay? So to show to you the extent of the work, okay, here you can see all those bubbles are actually committees, and the indirect involvements are here, and the indirect are here, okay? So it's global because we're talking about ecosystems, okay? And when I look at the SPADE, actually, SPADE is an ecosystem where you start from the field, and then you build out of the drones, let's say, a representation to help manage the field, okay? So with the three domains that we have covered, forestry, livestock, and the crops, okay? So basically, it means that we had to have a view on all those committees to understand what was going on. And you can see that some of them are very specific, like data-driven agri-food systems. So we registered to that precisely for SPADE, okay? And you have here coordination with ISO TC20 SC16, which is working on UAS. Okay, that's the idea. So having said that, so how do we deal with that? So we need to have a view that is allowing you to prioritize, okay? And we propose to use what you call the hourglass model, okay? The hourglass model was proposed in a paper by Communication ACM to express how the internet and Unix were created. Basically, you see this hourglass where below you have the possible supports, above you have the possible applications, and in between you have something which you call the sweet spot, okay? So where we provide the interface allowing above to make use of what is below, okay? And of course, IP is the example where below you had Ethernet, Wi-Fi, SONET, 5G, 6G. On top you have what we have today, okay? So we have discussed with the Commission to highlight not only this, but also to go towards standards. So we are talking about an ecosystem. We have stakeholders, we have capabilities, and out of capabilities, we have standards, okay? And the standards, they are here to help us make sure that the capabilities are deployed in the market in a smooth way and making business, okay? So, but the point is there are several ecosystems when you consider SPADE. In reality, sorry, what is very interesting is that we want to have this, the agriculture data space ecosystem, but the agriculture data space ecosystem need people who are collecting data. So we use digital twins, okay? So we have the agriculture digital twin ecosystem, okay? Which itself needs to use the drones. So we have the UAS. Okay, so we used to call it unmanned aerial systems. Now we call it uncrewed aerial systems or ecosystem. So we have several ecosystems that we want to use for SPADE. Okay, and of course, an agriculture data space ecosystem might use of the global data space ecosystem. So we have all those things to take into account. And for each ecosystems, you might have a bunch of standards. Okay, so I'm going to show to you how we can start with, say, a drone vision. Okay, so from the drone ecosystem. Okay, so if I have this here, I put a number of boxes. Each box is a standard. Okay, if it is in green, it means it's published. If it is in red, it means it's under development. Okay, and I also put here the committee from which it comes. For instance, TC20, so it's ISO TC20 SC16. 21384 uncrewed aircraft system. So it's a global vision, okay? And then you have all other things like here control detection avoidance system, tethered UAS, category of civil UAS, traffic management, and the like, okay? And you could say, yeah, this is about management, this is about control, this is about systems, this is about detection and trust, this is about interoperability, like UTM, so US traffic management data model for spatial data, okay? But those are, I would say, vertical standards. They are completely in the domain of UOS, and in SPADE, we haven't touched them, okay? We are using them, okay? We are users, we are not developers of standards. So what we have done is actually, we're focused on the ecosystems involving drones, okay? And now you can see that we have digital twin, IoT and digital twin data space, cybersecurity of drones, cybersecurity evaluation of complex systems, security and privacy of digital twins, and the like, okay? And I put here another tag, which is the S of SPADE, where SPADE has provided contribution there, okay? I'm not saying that SPADE did the entire standard, but we had a look and we contributed when necessary, okay? And so that's the message is, in reality, we are much more interested by the ecosystem involving the drones by the drone itself. Of course, we understand the drone's capacity is going to play a role, okay? So that's the first vision. And then I want to show a picture provided by Eclipse Foundation. It's an input from them, it's under discussion about how you can describe the hourglass model for data space, okay? So on the left, you have stakeholders like AI service providers. They use data, and you have data space governance stakeholders and data providers, okay? So if you look at capabilities, you see you have asset digital twin. So you could have a digital twin for a drone, okay? And but in reality, in the case of SPADE, we were interested by the application digital twin here, which is actually making use of data collected by the drones and possibly local specific digital twins for each drone. Okay, so that's dependent on implementation. And you see that one of the concern in the whole picture is security, privacy, digital sovereignty. So all those things, policy and credential management, connectors, digital sovereignty, they are part of the story, okay? So when we look at the standards, you could say that below, you need horizontal standards, so generic standards, but they must integrate the US domain, okay? So that then you are independent of the fact that it's a drone or not, okay? Then you have data space standards and data processing and management standards, okay? So this is how we can view. So I'm going to show now some examples, okay? So we can get into the digital twin and data space. And I'm going to start with, let's say, a vision from a data space viewpoint, okay? From a data space viewpoint, an ISO viewpoint, I'm going to use the data space standards. You see again the colors, okay? Red means under development, so they are under development, okay? And you see the number of green tags is very limited. So we are currently accelerating the development of standards, okay? And I want to highlight in yellow those which are directly influencing SPADE, okay? So the data space concept and characteristics, IoT and digital twin in data space, the digital twin reference architecture, which I will present later, cybersecurity evaluation of complex systems. How do we evaluate the cybersecurity part of a complex system, and security and privacy of digital twin. So, but this is not the whole picture. We need to take into account EU regulation and standardization requests. So on the left, you have current list of regulations, okay? They are all very recent, okay? And they are not complete, by the way, okay? But many of them led to requests to create standards. So you have 1, 2, 3, 4, 5 of them, okay? And one of them below is, for instance, for cybersecurity. I want to highlight, because I'm focusing currently on data, the one on data, okay? Where we had here a number of standards which are under making, under development, and they are called harmonized standards in the sense that if you use those standards, you meet them, then you have presumptions of conformity with the law, okay? So the effect is the following. So I'm taking again the same picture, but you can see that we have added here a standard from Sense-Senelec under making. It's going to publish next year, okay? Trusted data transaction. You have another standard on catalog for, let's say, semantic information, and then semantic assets, okay? And then here there is another standard, which actually I'm editing, on behavior and policy interoperability. So I'm going to present now to you the list of 3 standards, okay? Very shortly, because we don't have time, okay? So the first is 20151, data space concept and characteristics, okay? So there are DIS, which means Draft International Standard, and so very stable, okay? So some details will change, but very much so published next year, okay? Mid next year, I would say, okay? So it's a standard which explains the concept to create data space. And it shows that actually there are 2 types of interactions in a data space. One is the control, so how do you declare and publish your data? And the second is the orchestration, when you execute data sharing and data exchange, okay? So you have those 2 phases, and people, of course, always focus on the second one, but I tell you, the first one is extremely important for trustworthiness, okay? And then you have the roles. You have the provider, the recipient, the holder, and some optional like the agent, so third party, and observer like auditors, okay? And with this, it is identified that we need a governance authority. Each data space has a governance authority, okay? On the right, you have the outline of the standard. So you have the concept, and so for instance, discover data, and then you have the functional component, okay? Data use, data sharing, access, data space, okay? And that's it, okay? So to summarize that, I want to show the 2 main pictures of the standard. One is that it's all about policies. You have data use policies, data contract policies, so 2 organizations exchanging, data discovery, access policies, and data space policies, okay? So the picture here on the right is showing that sometimes you have participants several data space. So P1, P2, P3, P4 are participants. P1, P2, P3 are in the data space A and have, let's say, agreement on exchange, the green one, while P3 is also part of another data space with P4, and they have the red exchange. Okay, that's the idea. And actually, the 2 data space are isolated. That's the idea. Okay? So digital twin standard is the same thing, okay? And we have 3188, digital twin reference architecture, which I'm editing, actually. It's a draft international standard, and it provides the system fundamentals through what we call architecture view. It uses a well-known standard 42010 architecture description, which highlight the fact that we need to have concerns and viewpoints from stakeholders, and then the architect is providing architecture views, okay? We have 2 views. One is foundational, I'm going to explain that. And the second one is something allowing to create a Lego, so what we call patterns. So you can add additional capabilities to support energy, smart cities, smart manufacturing. Okay. So the conceptual model of digital twin is very simple. A digital twin, or one or several digital twin, can be twinned with what we call a cyber-physical target entity. Okay, I'm going to show an example. Okay, so then the digital twin has models of what's going on, algorithms, and then an interface to interact with this guy here. Okay, so there are two types of interface. A physical interface if it is a physical entity like sensors and actuators, and a cyber interface if this is a cyber entity like data on the French economy. Okay, and you would have to have a cyber interface to access the data. Okay, so in order to run, you need to have data. Okay, and actually, so you need to be able to observe and to have observable entities in the cyber physical target entity, which are actually data allowing to collect data on characteristic or property of the observable entity. Okay, so that's it. That's the architecture of a digital twin. Okay, but we need more. So how do we do this? We add architecture patterns. Okay, so you can add architecture pattern related to smart manufacturing, to health, and to agriculture. So, and I would say here we need those things to agriculture and actually having even an architecture pattern which connects to the drones. Okay, so this will be there. Okay, so when you build the digital twin, you add these patterns, and then here you can have the digital twin, which, for instance, SPADE has implemented. So the third standard I want to show is the interoperability. You create data, you want to exchange them, but you need to understand the data. Okay, so we have 21823-5 IoT behavioral and policy interoperability, which is at the committee draft levels. Actually, it's already dealt with as national level, and very likely next year it's going to be a draft international standard. Okay, so I need to explain now the principles for behavioral and policy interoperability and the requirements and how do we ensure that. Okay, this is the new things. Before we exchange data, now we exchange behaviors and policies. Okay, so how do we do this? So I'm going to skip this one, the outline, but I'm just going to show you how it works. Okay, so initially, until let's say the 6 years from now, before, we had two standards. One is 19941, interoperability and portability in the cloud, and 21823-1 framework. Okay, but actually currently we are working with the fact that the data we exchange include lots of metadata, and we need to extend that. Okay, so in cloud computing, they are working on edition 2. In SC41, we are working on edition 2 of part 1. I'm also the editor. And part 5, which is behavior and policy interoperability. Okay, so what is this about? Okay, so I need to show this. Okay, so when you have two domains or two participants that will exchange data, so in general, just before until now, we're exchanging syntactic and transport information. So I'm using this transport channel, and the syntax is this. Okay, and the rest, semantic, behavior, and policy, were there, but they were implicit because you didn't need to express them. Okay, today you need to express that explicitly. So you need to encode semantic, encode behavior, encode policy, so that actually you can exchange. Okay, and one of the example is the EU Research Center Code of Conduct for Energy Smart Appliances, which are requesting that the smart grid is interfacing with charging stations, with appliances, so that actually they take into account the flexibility requested for the grid. Okay, so in particular, if you have vehicles, the vehicles could actually inject electricity and power in the grid, okay, things like that. So we need to handle that. How do we handle this? We have what we call an interoperability profile. Okay, the interoperability profile will include aspects related to each facet. So in ISO SC41, we call them facet instead of layers. Some of you might be familiar with maybe let's say, a protocol layer. But there was a decision that we use the term facet because some of the, let's say, elements here are hard to put in a layer. Okay, so because, for instance, behavior and policy could be completely transversal. Okay, so what we have identified is that when you define an interoperability profile and you will exchange information about all those things, you need to have ontologies or concepts that we agree. Okay, so we use what you call a concept profile, a vocabulary that we agree, that then so we speak the same language. Okay, and then we can exchange that when we exchange information about semantic, behavior, and policy. Okay, so this is sufficient to have interoperability from this to this, and we have added this to handle regulation, because in reality, when you exchange information and when you interact, you want to follow the regulation. Okay, and therefore in the regulation you need to express the regulation in some way, and we call them constraint profiles. Okay, so if we are able to publish an interoperability profile that is using the same concept profile and that includes a constraint profile, then you can run a system, check it that it is consistent with the profile, and then be sure that actually you follow the regulation. So the last is actually the analytics, okay? And so AI, okay? So I have only one slide, okay? So this is the initial slide I showed to you with the ISO hierarchy, okay? But in reality, AI is everywhere. So when you look at this, then you can add a number of further standards related to AI, okay? And this is the current view. It's going to change because in the future, as we all know, it will have a far-reaching impact on what we are doing, and there might be other standards that come there, okay? But you can see that those I have selected are trustworthiness, okay? Security, privacy, data lifecycle, overview of synthetic data, okay? But there might be others such as agentic AI, human and agent collaboration, transparency, human oversight, and last but not least, the ethics. Okay. So in terms of conclusion, so this is what I have demonstrated. Okay, I use the same hourglass, and I show to you that I was able to show the importance of some standards. So 3188 is the digital twin. It can be used for the local digital twin here. In SPADE, we use for the global digital twin here. We have the data space, so 2151, and then we have interoperability, because otherwise we cannot discuss, and this is 21823-5. And of course, I put here plus others, because this is just an example, okay? But this is the way we can construct the things, and obviously what you want to have here, not having thousands of standards, but a minimum set of standards that you want to follow, so that actually then the market can grow. I think I'm done, Septième, so back to you.
Okay,
If you have
thanks.
questions.
Yeah. Thank you, Antonio, for the. It was kind of hard information to digest, but
Yes.
yeah, it was also kind of news for me as well that it's nowadays it's not becoming unmanned aircraft system again, but it's uncrewed aircraft system. It's kind of new as well for me.
Yeah, exactly.
So let's go back to the agenda that we're going to go to the Q&A session, and we have received at least a few questions, and I would like to read them one by one, and I hope that one of you can answer the question. But I think that Fleming also already answered by chat to its question, but I will also say directly here online. So the first question is coming from Erhan Bey. It's about I'm wondering the latest status of the forestry tree planted drone, which was started with your program to plant trees. So what is the latest development on on that innovation? I think that it goes to Aris.
Yeah, I can give a brief update because I'm following very closely this development. So the first phase of this development has finished. So the first prototype, of course, it was developed and it's tested and evaluated in real forests, so in real environment. The system now, so we collected the feedback from these tests. The system is also submitted to a patent. Now we are the team is moving to the development of the second version. So with new, more robust planting mechanism. So this will help the drone to be able to work also for rougher soils, more compressed soils. Also, we have a new flying platform to adjust the planting mechanism, so it's more robust as well, and it's larger. And also, we are the team now is also testing methodology to be able to compress with use inverse rotation of the rotors so that it can be pushing downwards more efficiently, so that it can the system can penetrate more easily to more rough terrain. And that's it. And then in the second open call, we are also launching a new development for a self-leveling mechanism so that the drone can be securely lands to uneven terrain. So this is the update for now. We will come up with new updates once we have more developments for that.
Yeah, you can also keep updating on our progress on our website, or you can also go through our channels, social media channels on LinkedIn, Mastodon, and also on X. But we also usually post our development on YouTube channels. So keep in touch on our social media channels. And then I would like to go to, oh yeah, I hope that already answer your question, Erhan. So if you have a follow-up question, please write down on the Q&A box. And then the second question is coming from Asbjorn. What is the standardized term for flying platform, drone or UAS?
Yeah, that's a good question. So it would depend. We can use both, okay? And the UAS, we just have the convention that we no longer say unmanned because there's a gender free, so we say uncrewed aerial systems, okay? And in ISO we use UAS, but in real life we often use drones, okay? So I would say let's keep both, and then that's it, okay?
I would like to add here, because the drone initially was about the term for the military drones, for bombing and so on. So we didn't want to use this term because it's for a bad purpose, not for, for something that we are using. So this is why the UAS came, and also the UAS comes for the system, not for the drone itself. So for the drone itself, it's the vehicle, so UAV. And then once you also attach the sensors on it and the other tools, then it becomes a system. So it's the UAS term.
Okay, thank you both for the answers. And yeah, let's go to the next question. It's coming from Elizabeth Matavela. How can SPADE's digital twin model be applied to real-time drone-based security monitoring while ensuring data security and also interoperability? I think that it goes to all
Yeah,
of you.
so to me, SPADE hasn't covered that, but the architecture can, okay? So it means that you have some specific aspects and requirements that you have to add, in particular about real-time aspects, okay? So one of the things that could be of interest in SPADE is that sometimes you need to have, and this is what Fleming showed about the data that we want to react within, he said 1 hour for forestry, okay? So you could have that kind of things, okay? For other types of application where it is much more real time, of course, you can always use a digital twin, but its architecture is important. You can have an architecture that is not fitting the real-time aspect. So, and of course, the devil will be the details, in particular in the wireless link, okay? So the wireless link has to be real-time. So we need to take that into account while ensuring data security and interoperability. This is definitely an architecture issue, and we better have, I'm going to call them the patterns, architecture patterns, to ensure security and interoperability, okay? And we've been working, I forgot to mention that, but there is a standard 27115 where we talk about the cybersecurity of complex systems, okay? And it goes that with the fact that you have to describe the architecture and to even evaluate and somehow prove that the architecture is good, it's half the job. Then you have to do a good implementation. So yes, we can start from that, but we haven't done that. And in the future, hopefully, in particular, our standard 3188 will accommodate that. And I'm the editor of the new standard, Security and Privacy of Digital Twin, that is done in SC27.
I would like to add about the digital twin, just to describe briefly what we developed in SPADE. So far we have the core platform, and then in this core platform, Gradient, who is developing the platform, and the digital twin, they have created the digital twin tool, which is embedded in the platform, where anyone can actually use this tool to develop any digital twin that they want to develop. So it's based on the basics middleware, what is the tool is providing. And currently we're using it for having a digital twin of drones, so we can assign drones and see in real time some specific readings from the drone and some aspects for the drone.
Actually, if I
And
can add something,
Mhm.
is the basic middleware is an open source for Eclipse, and it was
Yes.
initially designed for smart manufacturing digital twins, but it's completely generic. And then Gradient decided to use it because it includes many features which are of interest.
So I want to explain that, and also we have the peripheral platforms in SPADE for its pilot, different platforms that they all have separate digital twins themselves.
There is also a follow-up question from Elizabeth Matavella regarding the same topic. How can small or emerging drone companies in regions like Africa, South Africa, particularly start implementing digital twin technology using SPADE framework or open tools, even if we don't yet have the access to AU infrastructure?
Okay, so I suppose this goes for the infrastructure that has been developed through SPADE, I suppose. So many tools that we develop in SPADE are open source, which means that the code is freely available for anyone to use. I need to consult with Gradient about this.
I think the problem is maybe about the wireless communication capability, because I mentioned 5G, 6G, and maybe 6G is not yet, let's say, deployed, even though South Africa maybe are still in general ahead. Okay, so we have to see that, but you might have, let's say, drones that are actually working more, let's say, independently, and then you get the data later. Okay, so you have less real time, which is still of interest, by the way. Okay, we don't need the full real time stuff in many cases. Okay.
Okay, so next question is from Andrea Vianello. Which standard do you suggest for metadata about UAV datasets? Did you consider STAC specification? I think that it goes to Antonio.
So everything is open. So actually, I do not know, I have to say, which one SPADE is using, but I checked the stack and it perfectly makes sense to use it. And it's a matter of agreement between, let's say, the stakeholders, okay? So once you have agreed, then you decide the metadata you have, okay? And today there are many offers, so we will let the market decide. And of course, you might have situations where you have to submit to support several metadata. But at the end of the day, the idea is to go for standards, okay? Yeah, but stack is a standard in reality, okay? So it's just, do we select it in our profile? Okay.
Okay, the next question before we finish it. Within the R&D project, we are developing capacity to create environmental digital twins. The ISO or IAC 3188 will help us a reference. Is there any option to have access to the draft version before it's officially published? It's from Roberto
So
Monsorno.
I have to say that it's a tricky question because you have copyright issues. But when you have a project, it's very easy to get a liaison and to access the thing, okay? Other than that, it's quite hard, but then contact me for further discussion because, for instance, AIoTI, we have a liaison with the committee, and we through the liaison, the members, they can access and study the standard because they are expected to make contributions. Okay, yeah. So please contact me if you have an interest. And thank you for the question.
Okay, thanks. Since we already feel, do you still have enough time? Because do you still have at
Yes.
least two? Okay.
Go ahead.
So I'll just share the next question is about we can use decentralized AI to integrate in remote wilderness in, for example, Zimbabwe or South Africa. It's coming from Inger Medstenset from Norway. And the question is that may we extend the SPADE framework in AU Africa twinning for a digital twin? I think that it goes to everyone.
Yeah. I think this is more like agreement with Africa for Common Collaboration, but in principle, the architecture would allow it. Okay, and it's again a discussion between the two parties to do this. Okay, yeah, and to make it available. Maybe the question is, can we make it available for Africa to use the framework? And I would say yes. Just beware that SPADE is a research project, so the maturity is what we reach at the end of the project. Of course, the intention is to go further, and for the future, yes, I would say this could be quite of interest. Okay, and I'm pretty sure there might be even programs to encourage that kind of configuration in the future.
Okay, I think that's all the questions that we have received from all the participants. And thank you so much for everyone for attending. And we would like to remind you that the presentations are going to be available on our website, and we're going to send you at least a link if you want to revisit and also rewatch the webinars that we have just done. And for the other progress and the development of the SPADE project, it will be available on our social media channels and also on our website. So please stay tuned on our activities, and yeah, we would like to have you again on our next events. So thanks for everyone for attending, and yeah, that's the end of this webinar. Thank you.
Goodbye.
Bye.
Bye, everyone. Thank you.